Welcome back. So far in this playlist, we've focused entirely on supervised learning, where our data has labels. But what if it doesn't? Today, we dive into the world of unsupervised learning with one of its most famous algorithms, k-means clustering. So what is k-means? It's a simple and powerful unsupervised algorithm whose only job is to take a cloud of unlabeled data points and partition them into a specified number of groups, or clusters. The best analogy is a librarian faced with a huge pile of unsorted books. K-means is the process they would use to group similar books together on k different shelves, without knowing the genres in advance. The algorithm works in a simple, iterative loop. First, we initialize the process by randomly placing k points, called centroids, in our data space. Second, in the assignment step, every single data point is assigned to its closest centroid. Third, in the update step, we move each centroid to the average position of all the points assigned to it. We then simply repeat the assignment and update steps over and over again until the centroids no longer move. At that point, our clusters are stable. There's one big catch with k-means. You have to tell it how many clusters, k, to find in the first place. It can't figure this out on its own. Choosing the right k is a critical step and often requires domain knowledge or using statistical techniques like the elbow method to estimate a good number of clusters for your data. K-means is incredibly popular because it's fast, simple, and scales well to very large datasets. However, it has its weaknesses. As we just saw, you have to choose k manually. The results can also be sensitive to the initial random placement of the centroids. And finally, it assumes that your clusters are nice, spherical shapes, so it can struggle with more complex, irregularly shaped groups. Despite its simplicity, k-means is a workhorse for many real-world tasks. It's the foundation of customer segmentation in marketing, where businesses group customers by their purchasing habits. It's used to cluster news articles or documents by their topic. And in computer vision, it can be used for image segmentation, to group pixels of a similar color together. And that's k-means clustering, a beautifully simple and intuitive way to find the hidden groups in your data. Now that we've covered a range of algorithms, it's time to get rigorous about how we measure their performance. In our next lesson, we will explore the essential metrics for any classification task: accuracy, precision, and recall.